Hey, all right. We are here. This is Astronomy Daily Live for the 16th of January, 2018. I've got 2017 typed on my description there. So, yeah, that's kind of funny. So let me get this started. Hello, hello, hello. It says, I just noticed that I have the wrong year on the description there, so I have to fix that. Damn it! Just getting all set up here. I've got this system here, you guys, which is the camera. I've got another screen that I'm using to pop out the chat. Hey, CXXX right in front. Right in front. Hazard Smurf 420. Cheers, man. Or whichever one you are. Now, this is dihydrogen oxide, and I'm going to try to consume more of it tonight than last night. That was a real bummer. Let me check the audio, and you folks can tell me too if the audio sounds okay. Yeah, you know, the system that I have here sucks, right? You know, the lighting sucks. The video really sucks. The audio is you know. So, but you know, I'm starting at the bottom, and can't get much worse. So, you know, I think it can only get better. The telescope here in the background, that's a Celestron Nexstar 8 SE. I got that scope maybe about a year and a half ago or so. I like Celestrons. They're all right. This one seems pretty nice, and yeah. I've only got I've got two main complaints about this scope. Number one, it doesn't have a clutch, so the only way that I can operate this telescope is if I plug it in and use the paddle. So that sort of sucks, right? The other thing, which is more of a firmware problem than anything else, I'm gonna try not to slouch, is that this is on what's called an altitude azimuth mount, which means it just goes like this, just up and down and side to side. And so in order to point anywhere, it sort of needs to know some things first, and it does that by looking at 3 stars and doing sort of an alignment, and that alignment is pretty poor. There's sort of two aspects of that. Hello, Potato. How you doing, man? And I'm glad the audio is fine. Yeah, yeah. Well, there was a Smurf in here. I assume that there is still a Smurf in here. Yeah, yeah. So yeah, the scope is. I definitely haven't put it to work as much as I want to, but it's a good scope. It's a good scope. Right on the bottom there is where you would either put a eyepiece, or in my case, I put a CCD camera on there, science instrument, so I can actually collect some real data and do some real work. So yeah, very, very cool. Glad everybody is here. Glad everybody's here. It looks like I've got 5 viewers so far. That's very, very good. I noticed that the description that I put, it has the wrong year. so I will I'm gonna go ahead and change that at some point. It's just living in the past. So you live in the past. Oh well. I'm gonna try to see if this focus is any better. No, not really. the This is just this camera. This camera doesn't have any identification on it whatsoever. Okay, there's absolutely no make or model or anything else. It says megapixel. Sorry. Megapixel 10x digital zoom at 3.85 millimeters, and that's it. There's no other label. There's no other label on that at all. So, and I've done all the sort of the standard things in terms of updating drivers and whatnot. But if this has a digital zoom, I have no idea how it works. If anybody does have an idea, let me know. So, but the reason why I'm sort of operating such a shitty webcam is because the one that I use for my work, I've sort of modified, right? It usually doesn't have this thing on the front is my own mod, and it's just a 1.25 inch thing to slide into a telescope eyepiece thing. And then actually the software for this camera is pretty nice. You've got this is a pretty nice camera. Let me I can screen share and show you what it was, what it is here. Let's see, can I do that? Yeah. So that's what it is. It's a Logitech C525. So it's a pretty nice camera. I really like it. I haven't really run it through the ringer in terms of evaluating it in terms of being a scientific instrument. I have plans to do that, but so far I think I've had this camera. How do I get that? Oh yeah. I think I've had this camera, this setup for about 3 years, and haven't yet gotten around to actually doing any science with it yet. But I'm I'm feeling pretty motivated. You can sort of see inside there is the little CCD array right there. I forget what the array size is on this thing, but it's a pretty nice camera. Hello from Zebraville. Hey, how's it going? So yeah, this camera, Warnock 69. Yeah, this works good enough, and for now that's okay. I've no problem with that. I'm I'm looking over here at the live stream, and yeah, it looks fine. So I have no serious complaints or anything like this. So this is Astronomy Daily Live. I am doing a live astronomy discussion show every day at 2 hours UTC. And actually, one of the questions that I've got, I just have a few viewers in here, a couple of viewers, but I'll ask anyway. Is this a good time? I don't know. I sort of arbitrarily chose it for sort of my convenience, but you know, that's not. These kinds of things aren't set in stone. So I'm sort of, and I've already started to think about, you know, maybe I should have sort of a North American version of this, and also like a European / Asian, African uh, version of this, maybe, you know, like 12 hours apart or something like that. Where I'm located, I'm located in dark and quiet southeast Arizona, United States. Dihydrogen oxide. And was I? And so here, the time is Mountain Standard Time, and because I'm in Arizona, it's always Mountain Standard Time. It's always 7 hours behind Universal Time. So 2 hours UTC is 7 p.m. At my location. So yeah, you'll have to figure out for yourself what time it is wherever you are. But you know, that puts it at 2 a.m. In England, and you know, 3, 4, 5, 6 a.m. In Europe. Mid-morning, I guess, in Asia, and maybe mid-afternoon or so in Australia. So yeah, it works for some and doesn't work for others. So yeah, maybe a second one. Maybe have two, maybe 12 hours apart. I don't know. So 14 hours UTC and 2 hours UTC. I don't know. All right. Well, I hope everything is peachy where you are. Everything's good here. Have a little bit of high clouds here, but otherwise it's clear, and relatively speaking, it's pretty cold. But you know, relative to other locations, at least in the United States and the Northern Hemisphere in general, I'm in a pretty warm spot. I think it's getting, it's probably getting into the low 30s here Fahrenheit. So relatively speaking, that's not too bad. All right, I'm going to move on. I have 2 viewers. So I'll put my my science webcam away. Yeah, I really need to pull this out and do some real science with it. There's at least three projects that I'd like to do with this. I sort of have a continuing project with my Jupiter observations, Jupiter moon observations primarily. I'm doing photometric measurements of the moons of Jupiter, and as they orbit the planet, I can actually uh, uh, watch the brightness of each of the moons change. And the reason why is because I'm always seeing a different side of the moon as it orbits the planet. I see different sides of the moon, and based on the I guess you'd call that geography. I mean, geo is sort of Earth based, but anyway, the geography of the moons change, right? There are bright spots and dark spots and everything in between, and so as one sees a different side of each of these moons, the brightness of the moon will change. So that's kind of fun. The other thing that I can do with this is observe occultations of stars by asteroids, and so this would allow me to get some pretty good timing down, and it's cool. And then I can also use this to observe and detect meteor impacts on the moon. So those are at least three projects that I want to do with that, and I just have to get going on that. You got to calibrate all these things. These all these instruments have sort of their own internal signals, which sort of infect the signal coming from whatever you're observing, and so I want to be able to take all that out, right? I mean, I don't want noise or stray light or anything else that is sort of created by the instrumentation to be a part of my science data. I want to be able to just have the data. So I've got to be able to take all that out. And so I've got to make what are called calibration measurements to be able to subtract all that out when I go and process the data. So anyway, that is a webcam, and it's a nice one, and it's been sacrificed in quotes, for astronomy. No small sacrifice. No small sacrifice at all. All right, I'm gonna put this. I've got it in a little bag here so it doesn't get too dusty. So I'm gonna sort of go through the same little spiel as the past two nights, just because this is being recorded and folks are gonna hopefully see this later on. So this show is called Astronomy Daily Live, every day at 2 hours UTC, and it's just a casual, open-minded, skeptical, fun, and hopefully educational show about astronomy and related fields. All right, we'll see you later, Warnock 69 XXX. Peace out. So we're down to one viewer. Who is it? Is it Zebra? Is Zebra the last one on, or is it the potato? Who's still here? Make yourself known. All right, so for a newbie or an amateur or an advanced amateur or a professional, you are welcome here. I can speak at all levels, and I will. Most of the conversations I would like to be directed by you. I'll have some through, but I would just sort of like to talk astronomy. You all to sort of consider this as like a daily gathering of friends, out and talk astronomy for an hour or so. A lot of fun. And if you want to be on the panel, I can certainly send you the link. You just need to send me an email at cosmiclettuce@gmail.com, and I'll put you on live here. So I thought what I would do tonight, I have one silent viewer, and maybe I don't even have one silent viewer. Do I have no silent viewers? Let's see. It's not me. Okay, well, there's a silent viewer out there, and that is very, very cool. The only way that I know that is that there's one over here, and that's me, and it says that I've got 2 viewers. So, howdy, howdy. So I guess what I'll do is do a little bit of show and tell. These are some of the sites that I like to visit on the internet to get sort of my astronomy fix, and look at some really, really cool stuff. Or this So let's look at Mars first. If pull this up first before I share it, because I was looking at these just prior to going on, so I will back up and give you the highlights here. So let's see, can I do this? HiRISE. So this, what I'll show you here in a second, is the HiRISE site. Okay, so now I will share, screen share, chug, and we'll go here. So this is just uahirise.org, and what I do is I go into the catalog, and they update these relatively often. And these are just whatever images are coming down. HiRISE is an instrument on a satellite that is orbiting Mars. I think, oh man, I don't remember exactly what. I think this is on Mars Global Surveyor, MGS. I think. Don't quote me on that. But as you can see, they provide these little enticing little thumbnails here. And what I like to do, I actually call this Mars porn. Don't really go to that extreme, but you can click on any of these things, and then that's sort of an enlarged thumbnail, which I don't necessarily find interesting. What I find interesting are these black and white non-map things. My kitty is sitting behind the laptop, moving the camera. Let me, well, I'm just going to go ahead and keep moving with this. So you can zoom in on this, and what I do is I just sort of scroll around, and you know what an amazing landscape Mars is. You know, look at that. It's just mind blowing. Now, I don't claim that I can spend hours and hours and hours looking at these things, but I mean, how cool is that though? And the resolution here is absolutely astonishing. One pixel is a foot. It's like 23. Oh, is it a foot? Let's go back. Sorry. The pixel scale here, but they give, you know, this was acquired, and you know, sort of where they were looking. So 28.8 centimeters per pixel. Okay, and yeah, so that's about isn't that about a foot or so? Yeah. Yeah. So one pixel on here on this image is about a foot in size. So you know, these dunes, these guys here are, you know, just a few feet across. They're really small, really small. So you know, we could walk in between these dunes. So that sort of gives you maybe a little sense of scale there. All right, so we're just going to pan around here a little bit. I go all the way down one side, and then I scooch over, and then I'll come up the other side. And you know, depending on the solar angle, you'll get different kind of shadowing, and different kinds of things will pop out. It's just absolutely beautiful, you know. And this is most definitely one of the more tame things. Now there's a crater, and you can see all the dunes inside, and very complex structures in here too. Very interesting. Very interesting. So I'm going to move and see if I can find another interesting picture to show. Let's see, I was looking at that before, so I'm going to move on to something new so it's nice and fresh. That kind of looks a little... Dunes dubbed Kolhar, taken on the 10th of January of this year. So just, damn, that's just a couple of days ago. Let's see what this looks like. Huh. Okay. I think these are absolutely gorgeous and amazing. And you know, this is Mars. This is what Mars looks like from above, and it's just it truly is, you know, an alien landscape. You know, I mean, look at that. It's just insane. Just totally insane. I love it. Anything else here? Let's see. For those of you that don't No. Mars is the fourth planet out from the sun. Earth is the third. Mars is the next one out. Then we have a large collection of objects called the asteroid belt. And then Jupiter. But this is Mars. And I do this from time to time. I haven't actually quite a while. So, dark sediments and sinuous ridges in Medusae Fossae Formation. Let's look at that one. Whoever writes these descriptions, that must be a fun job though too, you know. It's like, oh man, what am I going to name this? Look at the shadowing here on that peak. You can really get a sense of the shape of the peak by looking at its shadow. See, so you know it's kind of hard to tell there, right? If that's a pointy top or a flat top. But if you look at the shadow, yeah, it looks definitely pretty flat. Look at all this stuff in here. Look at all that. And again, let me back up here and see what the is. So this is like 2 feet per pixel. Okay, 2 feet per pixel. So diving around in here, yeah, you know, these are on the order of 10 to 20 feet across. And so you know, very much a human scale here. And I like to imagine walking around here, and I wonder what it looks like from the ground. We actually have uh, 2 rovers. I think 2 rovers on the ground. At least 2 operating ones. So I just like to scroll around. As I said, I go all the way down, and then I go over, and I come back up like that. And you know these weird formations that just pop out of nowhere, right? And yeah, this must just be a geologist's dream. You know, they're having a lot of fun with these. A lot of fun with these images and all the data that's coming. Let's see, maybe we can do one more, and then I will move on. Got a wild kitty in the office tonight, and she probably just wants out, and she's noxious enough that I will get up and do something about it. So this is called dunes dubbed Arrakis. Of course I have to that out. Let's see. Dunes dubbed Arrakis. It's such a bizarre and alien landscape. I mean, look at the detail in this. I mean, is that that really looks like ice to me, right? It's hard to tell. It's hard to know for sure what that is. But that really looks like ice on top of those things to me. I don't know. But, can you imagine walking around in this? It's just wild, crazy stuff. It's actually not incredibly interesting. What you're looking for, which what you're interested in seeing or studying, right? Let's see if there's another. Let's look at this one, see if there's anything interesting there. There's an odd-shaped crater with that thumbnail. Let's look at the whole thing. A little dark, but yeah, it looks like just a big gash through the entire picture. It's a very, very complex landscape, you know? Just amazing. Absolutely amazing. Again, you know, look at the shadowing here. It's just, you can really get a sense of the shape of those edges. Yeah, wow, look at that. That's just so cool. So very cool. Let's see. Yeah, very awesome. So that's a great site. So that's just, if you can see that or not, at the top, it's uahighrise.org. So check that out. It's pretty awesome. I'm gonna go back to this and see how much the kitties ruin the view. Oh, hasn't ruined the view at all. And I still only have one viewer. Hello, viewer. Hang in there. We're hanging in. We're hanging in. Yeah. This is extremely awesome, extremely fun. The other site that I was going to show you tonight is a site that has the iris data. And iris these acronyms, you know, drive me insane. Let me get it here. Let me see if I can get it here. So iris is a spacecraft that is orbiting the Earth in a polar orbit, and it's a polar orbit configured such that it is almost always looking at the sun. So it's going around the Earth like this, and it's looking at the sun. You know, say the sun is that way, and so it doesn't matter, you know, that the Earth is turning. It's doing this, and so it's always pointing at the sun. And actually, it is using an 8-inch telescope, so it's the same size as this scope, and it is looking at the sun. So let me share that. Whoop. Let's see. So IRIS stands for Interface Region Imaging Spectrograph, and this is sort of the same thing as they put out data. They are chugging out this data, right? I mean, this data here. I need to. Do I need to share my screen? No, I'm good. This data here. Okay. Look at the timestamp on it. This is UTC. So this data was taken. This data was taken 4 hours ago. So you know, it's just brand new, fresh data. And what this is, these are images, very usually small portions of the sun. And occasionally what they do is they'll make us little movies that we can play here. So let's look and see. Let's look and see what this is. Yeah, I'm just going to let that run, and I can talk about it a little bit. This is looking at a sunspot, very much zoomed in, and you're not seeing it how I'm seeing it. This black line in the middle here is moving very rapidly back and forth, and that black line is actually a slit that is used to project this image onto an instrument called a spectrograph. And the spectrograph is able to separate the light out into different frequencies, different wavelengths of light. And depending on where it's looking, you're going to see a particular spectrum. And so as you can see, this is the sun is a very dynamic, active place. And at least in this little movie here that they're showing you, they're looking down into a sunspot, but they also have these sort of these spires shooting up out of the spot, but also if you sort of see on the lower right, they're curling back down as well and falling back down. So there's a circuit here going on, and you can see it flaring and doing what the sun does. Now, right there, you may have seen a whole bunch of white spots. That isn't any kind of a flaw or anything. That's actual electrical noise. And there it goes again. That noise happens when the spacecraft moves through the vicinity of the South Atlantic anomaly. The South Atlantic anomaly is a region in the vicinity of the Earth where the magnetic Van Allen belts, actually the electrically charged Van Allen belts, sort of dip a little low. And so as the spacecraft moves through that, it sees that electrical charge, and you get that noise. So that is very cool. So yeah, these kinds of things I can watch for quite a while. You can see all the bubbling and just a lot of activity going on here. A lot of really cool activity. All right, enough of that. We can let me I'm going to go through a little bit of this as well. Let's see how my number of viewers is going here. Still only one viewer. I'm glad you're there. Hope you're enjoying. I am. So yeah, very cool. Let's go back to Iris for just a little while longer. Oh, I got to share the screen again. Still getting used to all this stuff. I'm on a nice learning curve with all these things. Okay, so Yeah, so that's that guy. This is just an example of some of the spectroscopic data that is collected. And at the moment, I'm not going to get into these details, but yeah, this is a good example of data that is collected. I don't know if you can see on your screen, but there's a very faint black line right there. I hope that comes up. You can see it a little bit better over here. Okay, so that is the slit. It's an actual physical gap where the light goes through and goes into the spectroscope and creates that down here. And this is just a spectrum. It's actually, it looks like two different ones, two different wavelength ranges, looks like. All right, I'm going to go back a little bit more here. Let's go. All right, I'm going to have to page through this all again. But I hope you're getting sort of a good idea as to what's available. We in this day of age, we don't personally need any instrumentation anymore. I mean, who can afford who can afford to build and launch a satellite to go look at the sun, right? You can't do that. The cool thing is that at least here in the United States, these projects are funded by the public, by us. And so this is our data. And I think it's extremely cool that this particular project puts the data out so incredibly fast. I mean, hours after it's collected, we've got it. And I think that's just absolutely fabulous. So here's just another example. And again, the two or three things on the left here are the spectra, and then here's the actual image. And as you can see, this is sort of the edge of the sun here, right? Just right along here. And then you've got some stuff above it. And then here's that black line, which is the slit. Light goes through that and creates these. So as you can see, the spectrum actually goes above the edge of the sun here. So it's seeing all of this stuff too. And these widths, how wide this is and how bright it is and how it falls off and all that tells scientists about what's going on up there. Very, very cool. Cool. There's a little bit more. I don't know why that did that. There we go. Okay. See if there's any other interesting ones. They're this kind of data for people who don't really understand what they're seeing, or aren't doing any kind of research that requires this kind of data. Yeah, it can be relatively boring, I think, to look at because it all looks sort of the same. And for the most part it is, but bear in mind that there are lots and lots of solar astronomers who are looking at this data in minute detail, and papers are being written based on this data, and this is part of the scientific process, which I have talked about in the past couple of shows, where uh, uh, data collection sort of happens in two different places. The first is um, just sitting back and observing and saying what just taking a look and seeing what's around, right? And then once you look around a little bit, you can start to say, huh, well, that's kind of interesting. You notice some kind of a pattern or something, right? You say, oh, that's kind of interesting. I wonder what that's all about. And you start to make some guesses. And I wonder if this, let's see how well this JavaScript thing works. Okay, so this is sort of the scanning thing. So this is kind of hard to see. Really kind of hard to see what's going on there. So you make some guesses as to why you're seeing that kind of pattern, right? You go back and you collect more data. So data collection happens at least twice. One is sort of discovery, and then you go back again to test your theories, to see what's going on with that. These look all sort of the same. It's probably the same scanning doodah. I wanted to again sort of reiterate my motivations for doing this daily live show about astronomy. What I've noticed is that there's a vacuum, and I'm trying to fill that vacuum. As far as I know, there aren't any other daily live YouTube shows focused on astronomy. The other thing that I've noticed is that the hosts for the astronomy shows that are taking place are either very very dedicated folks who know their stuff really well, but aren't scientists. There are also educators and teachers who have shows, and there's also science science communicators. But there aren't any scientists doing this kind of thing, and the scientists are sort of are usually the guests, right? You have a guest, and they are the scientists, and in today's world, the scientists are sort of the high priests, right? So when we want answers to things, I'm going to stop sharing that screen. When we boom, when we want answers, we run to the high priests, and the high priests give us the answers. And I think that that puts a lot of pressure on scientists to come up with answers, where in truth, science isn't really about answers. It's a process of discovery and illumination, trying to figure things out, not necessarily getting the answers, because, and maybe you've heard this phrase, and I've experienced this uh, uh, thousands of times, and that is, um, once you start uh, uh, understanding what you're seeing, um, more questions arise, and so it's a circular thing. And so the scientists are sort of put on the spot to give these answers, where they're and they, I think they feel as though they have to be uh, certain. They're giving, this is how it is, and I don't think that's fair to the scientists to do that. Hold on one second. I have to let a kitty in. I have one kitty that howls at the door when she wants in, and it drives me insane. So I will be right back in 5 seconds. Okay, now she's in. All right, very cool. The third thing that I noticed is that the astronomy shows that are going on now are, at least appear to be, very scripted, and most of the people on there, a lot of times seem pretty nervous, and it just doesn't come off well, right? So this show is very casual. It's very fun. It's I would like it to be directed, the conversations directed by you. Now I've only got one viewer right now, so that makes it a little bit more difficult. And I continue to look at the chat, and there's just nothing going on tonight. So that's okay. That's all right. Anyway, so those are sort of the observations that I made about this medium that we're in now. And as I said, I'm seeing a vacuum. And the one thing about vacuums is that they like to be filled. They will be filled, and that is exactly what I'm doing. Is I am attempting, at least, to fill that vacuum. All right, very cool. Well, it has been almost an hour, and I have still one viewer. So I'm going to give that viewer a couple more minutes to chime in, any kind of questions, any kind of comments, anything like that. Definitely, if you're watching this in the future, comment down below. If you just happen to cross this channel and like what you see, you can subscribe. You can turn on notifications. You can hit the like button, and I think most importantly for me, is tell your friends about this. I want to talk astronomy, and I'm going to do this every single night, and at least for the foreseeable future, it'll be at 2 hours UTC every day. And yeah, so I guess for now I'm going to exit. I've got to get back up to the ship. So they only let me out for a short amount of time, and so my time is limited. I got to get things done, and then I got to get back up. So I think that time has come, and glad that you've watched, and I'm glad for the folks that came in a little bit earlier. They had to jump. No worries, no worries at all. Hope you enjoyed it. I will see you again in 23 hours. 23 hours from now, here, I'll beam back down, and we'll talk more astronomy. Okay, very, very cool. Thanks, everybody. Peace out.